Okay, Algebra 1, let's work through Unit 6, Lesson 8, Equivalent Quadratic Expressions. We've done a lot with quadratics lately. Remember, quadratics are any equations that start with an x squared or have an x squared in it. And then anything else, but the highest power is your squared. So let's begin with a warm-up. Explain why the diagram shows that 6 times 3 plus 4 equals 6 times 3 plus 6 times 4. This is really, as we present problems like this, we talk about the area in that square. The area in that square is 6 times 3, which is 18. And then the area in this square is 6 times 4 is 24. If I add those together, 8 plus 4 is 12. 2 plus 1 is 4. The area of those squares together is 42. Now that's the same as 6 times 3 plus 4, which is 6 times 7, which is 42. Okay, what we really did there is here we combine like terms and then multiplied. Here we can distribute. And then add. Right? Two different ways to do it. Two equivalent ways to work through it. And then draw a diagram to show that 5 times x plus 2. Okay, we'll say that's 5 units long. This is x units long. And this is 2 units long. So 5 times x is 5x. 5 times 2 is 10. So if I combine like terms, I would have 5x plus 10, which is the same as distributing. Equivalent. Moving on, what we're learning today is a really important math concept that's used a lot in the quadratic unit. It just took us 8 lessons to get there. So drawing diagrams to represent more products. Applying the distributive property to multiply out factors of or expand 4x plus 2 gives us 4x plus 8. I should say here 4 times the quantity x plus 2 gives us 4x plus 8. So we know the two expressions are equivalent. We can use a rectangle with side lengths x plus 2 and 4 to illustrate the multiplication. If I show you here, we're really, what I did in the last slide, the area of this rectangle is 4 times x, length times width. And then the area of this rectangle is 4 times 2, which is 8. And then we add those together, we get 4x plus 8 is the area of the two rectangles together. Okay, this first problem says, draw a diagram to show that n plus 2n plus 5, n times 2n plus 5 is 2n squared plus 5. They're equivalent expressions. Okay, not going to be drawn to scale, but if that's n, we can try to make that twice the length. That would be 2 times n, and this would be about 5. Now if I multiply the length and width of this rectangle, I get 2n squared. And if I multiply the length and the width of this rectangle, I get 5n. Now, if you don't remember how to multiply coefficients and variables, we're going to have to talk offline. Okay, that's something we learned in pre-algebra, and especially not teaching you face-to-face, it's difficult to know where you're stuck and where you're not stuck. So you're going to have to get in touch with me so that we can talk about it. All right, for each expression, use the distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. I have students that still draw diagrams every time they multiply, or every time they distribute, and that's fine. Okay, here I'm going to distribute. I have 6 times 1/3 n plus 6 times 2. Okay, 6 times 1/3 is 2n plus 12. And all you can do. Okay, distribute through. P times 4p plus p times 9. I have 4p squared plus 9p. I can't collect anything, so there we go. Okay, distribute through. 5r times r plus 5r times 3/5. This first one is 5r squared. Here I can simplify that fraction, plus 3r. Of course, I'm running out of space. Normal problem with me. Here I have parentheses with something on the outside to the right. Okay, that really doesn't matter. I can still distribute through. I'm just going to go that way. So I have 0.5 w times w plus 7 times w. So that gives me 0.5 w squared plus 7w. Collect anything that's the same, which is nothing, and you're done. Right, using diagrams to find equivalent quadratic equations. Here's really where we start talking about things called foiling, if you've heard anyone talk about foiling in algebra before. That's really what we're doing, and I'll get to this in just a moment. Let's work on something that's a diagram first. So here's a diagram of a rectangle with side lengths x plus 1. So this length is x plus 1, and this length is x plus 3. Using this diagram to show that if you multiply those two side lengths, or you find the area of that rectangle, these two binomials and this trinomial are equivalent expressions. So I'm going to find the area of each one of these smaller rectangles. Okay, x times x is x squared. X times 3 is 3x. X times 1 is 1x, but you do not have to write the 1. And 3 times 1 is 3. Now let's collect everything that's the same inside of there. This gives me x squared, because it's the only one with a raised to the second power. I have a 1x and a 3x. Those both have an x as a power, so I can add them together. And then a 3. So the two binomials and the trinomial are equivalent, because, goodness, I can do 3 times 2 is 6. Those are equivalent. Just because you're multiplying them doesn't mean they're any different. Okay, they're equivalent. Now I'm going to show you that same problem with foiling. You may be interested in, I've had some students that call this method right here the Pundants square method. Not exactly accurate, but it makes sense to them, so I'll support it. Okay, the Pundants square method, where they just multiply the top and the bottom, and then they collect like terms on the inside. I grew up calling this foiling, because that's first term times first term. So first times first is x squared. Outer is the O. Inner is the I. And last is the 3. And then you collect like terms. Now I'm going to use the foiling method mostly. I will go through the Pundant square method just to model it one or two more times, and you can use whichever one you would like. So let's work through these. I'm going to need a new slide though, aren't I? I don't have enough space. I'll do A here. So x plus 5 squared, and my diagrams are never going to be drawn to scale. I I do my best, but. So I have x and 5, x and 5. And we're just multiplying the row and the column. So x times x, 5 times x, 5 times x, and 5 times 5. So what I'm doing is row and column, right? Now I collect like terms. And I always cross things off when I collect like terms. X squared, 5x plus 5x is 10x. And I can't do anything with a 25. So we got that one. All right, I'm going to transfer these to another slide. All right, let's look at B, 2x times x plus 4. So I need to do the x plus 4 and the 2x. So if I multiply the row and the column, the top and the side, I get 2x squared and 8x. Collect everything, 2x squared plus 8x. This one I'm just distributing. There's no Punnett square diagram, right? Let's try C. So I'm writing down here now 2C. Okay, when I do D, we're going to do just the foiling method. I don't care which one you do. I really don't. And you don't have to draw everything to scale. Okay, 2x times x is 2x squared. And then just plain old x. 2x times 3 is 6x. And then 3. Collect like terms. I have 2x squared. X plus 6x is 7x. Remember, there is always a 1 in front of a variable. And then plus 3. Let's try 2D. X plus m, x plus n. I'm going to do first, outer, inner, and last. Can't collect anything there because there's way too many variables, right? All right. And as usual, if I would look ahead, I would see now we're doing this without drawing a diagram. So we're just going to FOIL these. Again, if you're having a hard time multiplying variables and numbers, we need to talk one-on-one, okay? It's not a big deal. We just need to do some review. Okay, x times x. It means I have x squared, x times 6. It means I have 6 x's. X times 2, I have 2 x's. And then 12. Okay, collect like terms. These are like. Collect them, means add them together. Cool. And as usual, I did not plan out my whiteboard very well. Let's try this last one. I'll fit it in right here. Okay, first times first. Outer. Inner. And last. Collect your like terms. Okay, those two in the middle are like, and you're done. So that really is the meat and potatoes of today's lesson. This last slide, though, I'm going to show you. It's kind of interesting. It should be at the end of your classwork packet. So this is another way that they have presented to FOIL. If you notice, there are some, like this is sort of highlighted in green and that's in red. So they're taking this, let's do this term and distributing it through this binomial. So that term and that binomial, which becomes x squared plus 6x. Okay, that's what I'm doing, just in a different order. And then we have this term through the same binomial. This, not term, yeah, through the same binomial. which becomes this mess. Okay? And then they've collected like terms in a very, they're showing all their work way. Let's do this. One more thing and then I'll let you guys go. They've collected like terms right here. Okay? And their final answer is x squared plus 8x plus 12. So it's foiling, but you don't have to memorize the word foil. Good job.